Okay, scholars, you are on page 4 of problem set 1.19. You should have recognized a pattern from when you were multiplying the amount of money that tutors or teachers were giving you by times 10 and times 100 and then times 1,000 and times 10,000. You should have got that explanation out on that last piece of paper, and now we're just going to formalize some of that information that you learned. You should have seen that the pattern, well, let's just go through the pattern over on the right here. When we multiplied 15 times 10, we should have ended up with 150. And I'm putting a decimal point right there, 0.0. It's the same thing as 150. It's 150 and 0 tenths. 0 tenths is the same thing as 0, so really we just have the whole number 150. This one is 32 and 1/10, or $32.10. This is what you're getting from Miss O'Brien when you were trading, or Mr. Locke when you were trading in, and he was giving you 10 times the amount back. And then for 7 cents, you would have gotten 70 cents back. And the pattern that you should have recognized is every time you multiply it by 10, you end up moving the decimal over one place to the right. It goes from there to there, from in between the 3 and the 2 to in between the 2 and the 1. So from there to there, it moves one place. And from in between the two zeros here to in between this 0 and this 7. Right? And it is then 70 cents. And remember, we can add zeros to the end of these all we want because they're just placeholders, right? This is 7 tenths. It's also 70 hundredths if you add a 0. It could also be 700 thousandths. It could also be 7,000 10,000ths. I could keep adding zeros for as long as I wanted to, and it doesn't change the value of that decimal number. So the pattern that occurs is that every time you multiply by a factor of 10, the decimal point moves one place to the right. When you multiply by 100, you're multiplying by 10 twice. Therefore, the decimal moves 2 places to the right. So when you traded in with Miss O'Brien, she gave you 100 times back the amount that you gave her. Your decimal moved 2 places to the right. You went from 15 and you moved it 2 places to the right, and you ended up with 1,500. And your decimal is right there now instead of being there. When you had $3.21, and you multiplied it by 100, you should have gotten $321. Your decimal is there, it was there, and I could add zeros there. When you multiplied by 7 cents, you should have ended up moving it 2 places to the right, and it is $7. Your decimal is now there, I could add 2 zeros, $7. So every time you multiply by 10, you move the decimal over one place to the right, and when you multiply by 100, you're doing that twice, and so you move it 2 places to the right. Using that information, I would like you to predict what do you think the product of 10 times 12 hundredths is going to be. Predict what that is, and then do out the multiplication. And then predict what you think 100 times 3 and 7 tenths is going to be. Predict what that is, and then do out the multiplication. Pause the video, and then when you're done, play it again. Okay, you are back. You have done out this work to figure out what 10 times 12 hundredths is. And if you did this right, you moved this decimal one place to the right because you're just multiplying by 10, and you end up with 1 and 2 tenths. When we check this work, you can multiply by 12 hundredths times 10, and you end up with 120 hundredths. 120 hundredths is the same thing as 1 and 20 hundredths. Or 1 and 2 tenths, either way, right? And this is 1 and 2 tenths like this. You could have also had 1 and 20 hundredths like this, right? So we predicted it, and it worked right here. 1 and 2 tenths or 1 and 20 hundredths is the same thing as what we predicted. Crazy. If you did this for 3 and 7 tenths, you should have moved the decimal over 2 places to the right. It is going to be equal to 300. Let's see. We moved it over one place to the right, and that's 37. If we move it over times 37 times 10, 37 times 10 is going to be 370. If we move it 2 places to the right, we end up with 370. let's do this out. 3 and 7/10 times 100 is 3 and 7/10 times 100. That equals 300 and 700 tenths. 700 tenths is equal to 70. And so this is 300 plus 70, and that is 370. So our answer is 370 using both methods. And I'm going to show you one more time what happens when you multiply 3 and 7/10 by 100 using our trick. The key thing that you have to remember is that when you add a 0 to the end of a number, you make it 10 times larger. You're also moving the decimal one place to the right. Let me show you down here what I mean by that. 3 and 7/10 times 100 is the same thing as 3 and 7/10 times 10 times 10. 3 and 7/10 times 10 is 37 times 10. Move the decimal one place to the right to get 37. 37 times 10, as you know, is 370. So even though we're adding a 0 to the end, but that's the same thing as adding a decimal point. If we have 3 and 7/10 and we want to multiply it by 100, we can move it once, twice, and this second spot adds a 0. And so that becomes 370. Okay, turn to your page, and we're going to talk about what happens with 1,000 and 10,000. When you multiply by 1,000, you're multiplying by 10 3 times. Therefore, the decimal moves, how many places do you think? 3 places to the right. And when you multiply by 10,000, that's 1, 2, 3, 4 tens in there. You're multiplying by 10 4 times, and therefore the decimal moves 4 places to the right. So if you're multiplying 321 times 1,000, you can move the decimal 3 places, 1, 2, 3 to the right, and you end up, and this is a 0, right? So it's 3,210. If you multiply 10,000 times 7 cents, you are going to move this decimal point 0.07. How many places? 1, 2, 3, 4 places. 1, 2, 3, 4. And there's 2 zeros there. 4 places to the right means 700 times 10, or times 10,000, excuse me, is 700. You can think about this like the same ways that you think about money. The reason why this works, and I'm going to read this, please track while I read. The reason why this works is because our number system uses 10 as the point to trade in for a new higher unit. So when you multiply by 10, it's the same as moving to the next higher unit. For example, notice the movement of decimal when we trade in the following. I want you to think about 2 pennies. I have 2 pennies right here. Okay, and I'm going to tell you that I'm going to multiply these 2 pennies by 10 each. What's going to happen to them? How much money am I going to have? And what could I trade the pennies in for? Think about it. I have 2 pennies. I'm going to multiply each of these by 10. How much money will I have? Right now I have 2 cents. If I multiply it by 10, how much money will I have? And what could I trade it in for? So if I multiply these 2 pennies by 10, I'm going to have 20 cents. There's 10 pennies here, 10 pennies here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 rows of 2 is 20 pennies. That's 20 cents. And if I wanted to, I could trade that in for 2 dimes. That's all that you're happening when you're multiplying 2 pennies, which is the same thing as 0.02, 2 cents, or 2 hundredths. You're multiplying that by 100, or excuse me, by 10. And you're going to move this decimal 1 place to the right, and that's going to equal, instead of 2 cents, it's going to be equal to 20 cents. Okay. It's going to go between here and here. If I wanted to, I could add a 0 to the end of that for 20 cents. 2 pennies 10 times is the same as 2 dimes. I could trade them in for 2 dimes. And 0.2 represents 20 cents, or 2 tenths. 2 tenths is 2 dimes. And then they should say, or 2 hundredths 10 times is the same thing as 20 hundredths, or 2/10. 2 pennies 100 times is the same as, we're going to think about, if I had these 2 pennies and I multiplied them each by 100, how much money would I have? Think about that. If I multiplied them each by 100, I would end up with 100 pennies on each side, and that would be the equivalent of $2. If I multiplied each of these pennies 100 times, there's 100 pennies in a dollar, and so 2 cents times 100 is $2. Okay, now how does that work when we are multiplying and moving the decimal to the right? 2 cents, or excuse me, 100 times 2 cents. I'm going to move the decimal 2 places to the right, and I'm going to end up with 2 decimal point, and I can add zeros all I want. That's $2, or 2 wholes, 2 ones, right? 2 and 0 hundredths. 2 pennies 100 times is the same as $2, or 100, and it really should say 2 hundredths. 100 times is the same as 2 wholes, 2.0, and that's 2 wholes. 1 dime 10 times, the same thing is going to happen with the dime. If I have a dime and I multiply it by 10, if I have 1 dime and I multiply it by 10, I'm going to have 10 dimes. 10 dimes is the same thing as a dollar. Watch what happens when I have 10 dimes. 10 times 1/10, or 10 times 1 dime, move it 1 place to the right, is 1, or $1. 1 dime times 10 times is $1. 1/10 10 times is the same as 1 whole. 1 dime 100 times, so if we had 100 dimes, it would be the same thing as $10. Or, this should say $10. This should just say, this should say 10 wholes. And this should say 1/10. And the way we would show this is 1/10 times 100. We would move it over once, twice. We would be left with a 0 in that spot. $10. Okay, with that strategy, you should be able to complete the rest of this packet.